Today, low visibility in the critical phases of the flight is one of the most disruptive factors in European aviation and causes about 50% of arrival delays. In 2007 alone, at London's airports, more than 57,000 flights were delayed because of the weather. Delays cost about €1 billion per year. Air traffic in Europe is expected to grow steadily over the next decade. To support this growth, it is vital to increase the efficiency of the air transportation system, thus reducing the impact of difficult weather conditions. The ALICIA project aims to develop new systems which will permit aircraft to operate in almost all weather conditions and to fly closer together at lower risk, simultaneously driving down air transport delays. The key to achieving this goal is presenting the crew with better, real-time information in any phase of the flight. In order to do this, we need to optimize the design of the cockpit, making it a better place where the right information is always available at the right time for the pilot. Information about weather and surrounding air traffic, coming from both ground and airborne sources, will be presented on touchscreens, head-up displays, and 3D audio, enabling the crew to make quick and effective decisions. ALICIA will integrate both innovative and existing technologies to create a new, scalable cockpit architecture, which can be tailored to the specific needs of any type of aircraft. ALICIA's goal is to achieve effective all-condition operations. This means allowing aircraft to fly with the same safety and performance in almost every weather condition. The solutions envisaged will cover every phase of the flight, from taxiing to cruising, approaching, and landing. A common philosophy guides the development of solutions for different aircraft types, and also for helicopters, taking into account the different conditions in which they are flown and the specific needs of helicopter crews. The ALICIA project started in 2009 and will last until 2013. The project began by defining operational and technological requirements of the cockpit of the future and conducting a thorough recognition of existing and emerging technologies. Selected technologies will be integrated in the design of new cockpit prototypes, which will finally be evaluated through simulators. Dockable displays can be used for flight planning in an office or at home. Routes, weather forecast, and all aspects of flight preparation can be generated before pilots' arrival at the airport. This allows them to become familiar with the new route. Consequently, this may lead to quicker procedures on board of the aircraft, which could have a positive influence on delays. Taxi operations now rely mostly on direct vision through the windscreen. In low visibility conditions, pilots cannot easily identify obstacles and navigate on taxiways and runways. Another consequence of traffic growth is increased risk of runway incursion. Information from the aircraft's navigation and positioning system, digital maps of the airport area, and brake and steering cues can be presented on a head-up display, a transparent surface in the pilot's sightline through the forward cockpit window. While the pilot looks through the display to see the outside world, the system can effectively make up for lost visibility, allowing the pilot to perceive the same position clues he would ordinarily receive by looking outside. While flying towards bad weather, real-time information is presented to the crew that allows them to manage a large quantity of data coming from different sources, clearly selecting, at any time, the data that are the most relevant for the crew. The system presents to the crew the weather conditions around the aircraft and detects potential threat. Weather data are collected from different sources and tailored to the aircraft's requests and specific needs. The crew makes quick decisions based on these data, and replans the flight when necessary. A new, safer route is calculated by the onboard computer and sent to ground control for approval before being selected. The landing phase is particularly critical in bad weather conditions. As the aircraft approaches ground with low visibility, the pilot must be aware of potential obstacles, such as high buildings or wires. A synthetic vision system can be displayed on the cockpit's head-up display. It utilizes precise navigation sensor inputs and data from terrain, obstacle, and runway databases to generate a synthetic, three-dimensional view of the external aircraft environment, leading the pilot to land just as safely as he would with perfect visibility. Helicopters pose specific requirements, as they are often flown in extreme conditions, in particular when servicing offshore platforms or when used for rescue operations during natural disasters. The solutions envisaged for commercial airplanes must be adapted to the specific conditions found on a helicopter. For example, head-up displays are replaced by head-mounted displays, which give the same visual information with the necessary stability and allow the pilots to see the information presented even when they are not looking through the front windscreen. Active stick controls allow the pilot to have a sensory feedback about the forces applied on the aircraft. In addition, 3D audio can effectively help pilots to communicate with ground stations and avoid obstacles. To achieve its goals, ALICIA brings together all the key players in European avionics. 19 industries, 7 research centers, 11 small and medium enterprises, and 5 universities are cooperating, preparing the future of European air transportation.